10 days. That's the time we have. In 10 days, on March 16th, 2026, Comet 3I/Atlas, a piece from another star system older than our Sun, carrying chemistry locked within it since before Earth existed, will make its closest pass to Jupiter, and then it will start its final exit from our solar system forever. This is the last chapter, and almost no one is covering what's actually about to occur. Let's discuss what March 16th truly means, why the timing of the full scientific data release isn't a coincidence, and why there's one spacecraft at Jupiter right now whose role in this story has barely been mentioned at all. Hold on to all that, because this needs some setup. You know the broad story of 3I/Atlas, discovered July 1st, 2025, past the Sun in late October, past Earth in December, organic molecules detected. Chemistry from another star system venting into our solar system for the first time in recorded human history. The JUICE spacecraft captured it on film. The Sphere-X telescope read its chemistry. SETI pointed every serious radio telescope it had at it and listened. You've seen all that. So let's begin exactly where things stand right now. Today, March 6th, 2026. And what's coming down the timeline in the next few weeks. Three things are converging at the same time, and the overlap isn't something you can dismiss as mere coincidence. First, March 16th, the closest approach to Jupiter. At that moment, 3I/Atlas will be 53 million kilometers from the largest planet in our solar system. That's closer than JUICE was when it photographed the comet in November. And JUICE got 120 science-quality images from that distance. Jupiter has a gravitational field 318 times stronger than Earth's. It will pull on this comet. It will interact with it. And Jupiter has a spacecraft orbiting it right now. The Juno spacecraft has been orbiting Jupiter since 2016, studying its atmosphere, its magnetic field, its auroras. In 2025, when scientists calculated the Jupiter flyby trajectory for 3I/Atlas, a study was published co-authored by Avi Loeb, specifically examining whether Juno could be used to intercept or observe 3I/Atlas at Jupiter. The conclusion: it's possible, but Juno is running low on fuel. Its engine has issues. Redirecting it carries risk to the primary mission. No official announcement has been made that Juno will be used this way. None. But it's there. It's orbiting Jupiter right now. And in 10 days, an interstellar comet from another galaxy's worth of space is going to pass through its backyard. We don't know what Juno is going to do. Second convergence. The JUICE full data set. After 5 instruments aboard the JUICE spacecraft were used to observe 3I/Atlas in November 2025, spectrometers, particle sensors, ultraviolet detectors, cameras. That data was locked inside the spacecraft for 3 months because JUICE was shielded behind the Sun and couldn't transmit. It finally arrived at ground stations in late February, and the science teams have been working through it ever since. The full published results are due at the end of March 2026. That means the most complete close-range data set ever collected on an interstellar object lands in the public domain just weeks after the Jupiter flyby. Whatever the Jupiter encounter does to 3I/Atlas, whatever it reveals, whatever changes, whatever instruments capture, the scientists are going to be writing it up at exactly the same time they're also processing the JUICE November data. These two data sets are going to be analyzed simultaneously, and we won't see the full picture until both are in. Third convergence, the Parkes Observatory. We'll come back to that. Before we go further, if you found the channel in the last few days specifically because of 3I/Atlas, subscribe right now. The next few weeks are going to produce data releases and news that will require real breakdown, not headlines. This channel is going to be here for all of it, and I don't want you to miss the Jupiter encounter coverage. Hit subscribe and keep watching. Let's talk about what the Jupiter flyby actually is physically. This is something the headlines have gotten badly wrong in how they frame it. The comet isn't flying past some distant backdrop. Jupiter's gravity well is real. Jupiter shapes the orbits of everything in the solar system. It redirects comets, captures moons, deflects asteroids. The 3I/Atlas trajectory will be affected by this encounter. Not dramatically. The comet's speed is too high for Jupiter to capture it because 3I/Atlas is moving at 58 kilometers per second relative to the Sun, far beyond any planetary escape velocity. By March 16th, it will have slowed from its peak speed of 68 kilometers per second at perihelion to something around 40 kilometers per second as it climbs away from the Sun, still moving with a hyperbolic excess velocity that no object born in our solar system has ever matched. But Jupiter will bend the path. Jupiter will interact with the magnetosphere of this object, with the charged particles streaming off its nucleus, with whatever remains of its coma. Scientists calculated that Europa Clipper, NASA's spacecraft on its way to Europa, was potentially immersed in the ion tail of 3I/Atlas back in late October and early November. An interstellar comet's ion tail brushing past a spacecraft going to look for life under an icy ocean. That moment has already happened. We just don't have the full data back yet. Now, here is the part that deserves to sit with you for a moment. By the time 3I/Atlas passes Jupiter on March 16th, it will be 5.1 astronomical units from the Sun, way out beyond the orbit of Mars, beyond the asteroid belt, heading toward deep space. The Sun's heat is no longer tearing into its surface the way it was in October and November and December. The eruptions that SphereX documented in December 2025, when scientists described the comet as, quote, full-on erupting into space and releasing a cocktail of chemicals that hadn't been exposed to space for billions of years. Those eruptions are quieting. The comet is cooling. The chemistry that was being released is now dispersed. Whatever was being read by the instruments, the methanol, the methane, the cyanide, the organic molecules that on Earth are signatures of biological processes, that window when the deepest interior of this thing was opening up and venting outward is closing. Past the Jupiter flyby, the comet heads toward the inner Oort cloud. It will reach 2,000 astronomical units from the Sun around the year 2018. It will reach the outer edge of the Oort cloud in approximately 8,000 years, and it will never return. Not in any human time scale. Not in any time scale approaching civilization. This is the last time any instrument will be close enough to read what's inside it. And here is where the timeline becomes something you cannot dismiss. The JUICE full data set, the spectrometers, the particle sensors, the ultraviolet data, all 5 instruments, is coming out at the end of March. That is not before the Jupiter flyby. It is after. So we are going into the final planetary encounter with the most complete spectroscopic analysis of this object still sitting in the notebooks of researchers who haven't published yet. We are watching the last chapter of the comet's visit to our solar system without having read the results of the most thorough investigation ever done on its chemistry. Does that seem unusual to you? Because it should at least give you pause. There's nothing sinister about the timing. Science publishing is slow. Peer review takes time. The data only arrived in late February and takes weeks to process. This is all completely normal. But from the perspective of a person trying to understand what this object actually is and what it brought with it, we're watching the ending of the story before the middle has been explained. Let's talk about the chemistry, because this is where the story gets genuinely strange in ways that most coverage has not grappled with honestly. And I want you to stay with this part, because if you leave this video without understanding what was inside this comet when it opened up, you're missing the thing that actually matters. The James Webb Space Telescope found that 3I/Atlas is unusually rich in carbon dioxide. Not just a little rich. Extraordinarily high CO2 to water mixing ratios. One of the highest ever measured in any comet, solar or interstellar. Scientists studying this had to confront 2 competing explanations and could not eliminate either one. The first explanation: the comet formed very far from its parent star, beyond the CO2 frost line, and simply has more CO2 baked into its structure than typical comets. That's a completely natural explanation. The second explanation: the comet has an unusually thick insulating crust that's hiding water ice underneath, which is why we're seeing more CO2 relative to water than we'd normally expect, because the water can't escape. That crust, according to the researchers, will be the result of billions of years of bombardment by cosmic rays during its journey through interstellar space. The radiation hit the surface over and over for billions of years and processed the outer layer into something hard and sealed, like a shell. And inside that shell, untouched, unchanged, the original material this thing formed from around a star that was ancient when our solar system was still forming. When Sphere X punched through the shell in December, when the sun's heat finally reached deep enough to break open the sealed interior, what came out was described as a cocktail of chemicals that hadn't been exposed to space for billions of years. Carbon-rich material, organic molecules, rocky debris being ejected from the nucleus in chunks too large for solar radiation pressure to push away. Chunks of an interstellar comet being released into our solar system's interplanetary medium right now. Some of that material will be captured gravitationally. Some will drift. Some percentage of it, over time scales that dwarf human civilization, will fall somewhere. Stop and think about that for a second. Not in the abstract way scientists describe it in papers. Think about it literally. A chunk of material from a star system we have never seen, that formed in conditions we cannot model, around a sun that may no longer exist. That chunk is now somewhere in our solar system. It arrived sealed. It opened, and it left pieces behind. Comets seed planetary bodies with chemistry. This is not speculation. This is established planetary science. The question of whether 3I/Atlas can do the same thing, whether material from another star system can be deposited into our solar system's chemistry, has never been tested before because we have never had an interstellar comet erupt and vent in the inner solar system before. Not while we were watching. Not with instruments capable of reading what came out. And here is the detail about 3I/Atlas that the popular coverage has systematically avoided, stating plainly, this object has a higher eccentricity than any object ever observed in recorded human history. 1I/Oumuamua had an orbital eccentricity of 1.2, slightly hyperbolic, meaning it was going just fast enough to escape the sun's gravity. 2I/Borisov had an eccentricity of 3.4. 3I/Atlas has an eccentricity of 6.14. 6.14, that is not slightly outside a bound orbit. That is a trajectory so strongly hyperbolic that it appears almost straight, barely curved at all by the entire gravitational field of our sun. This object entered our solar system already moving at 58 kilometers per second relative to the sun. For comparison, the Earth moves at about 30 kilometers per second in its orbit. This thing arrived moving almost twice as fast, and it never slowed down meaningfully. It was always going to pass through and leave. There was never any possibility of it staying. It was always just passing, always en route to somewhere else that we will never see and never know. Following an orbit through the Milky Way galaxy that has been bringing it closer for somewhere between 3 and 14 billion years. The uncertainty in its age is that wide. It might be roughly as old as the solar system. It might be almost as old as the universe. We genuinely do not know what formed it, where it formed, or what conditions existed in the protoplanetary disk it came from. What we know is that by the chemistry profile, the anomalously high carbon dioxide, the low carbon chain species, the presence of nickel vapor without corresponding iron, the organic molecules sealed inside. This object is not simply a duplicate of solar system comets caught in a slightly different orbit. It is made of different stuff, processed differently, reflecting conditions in a stellar system with different element abundances than our own. Every time scientists compare it to solar system objects, something doesn't quite match. And the Parkes Observatory, among the telescopes that participated in Breakthrough Listen's formal search for technosignatures from 3I/Atlas, 5 observatories contributed data. The Allen Telescope Array in California observed and published. The Green Bank Telescope in West Virginia observed and published. The Meerkat Array in South Africa observed and published. The Vera C. Rubin Observatory in Chile observed and published. All 4 found nothing artificial officially. No technosignatures. No engineered signals. 3. I/Atlas behaves as expected from natural astrophysical processes. The Parkes Observatory in Australia, one of the most famous radio telescopes in the world, the 64-meter Murraying dish, observed 3 I/Atlas on July 31st, September 12th, and October 5th, 2025, 3 separate observation dates. In the final published report from Breakthrough Listen, those results were not included, not described as negative, not described as positive, simply not yet available. And as of today, March 6th, 2026, they remain unpublished. 3 observations from one of the world's great radio telescopes on 3 different dates spanning the period of the comet's initial approach and maximum activity buildup. Not published. There's almost certainly a mundane explanation. Data pipelines, peer review, institutional publishing schedules. Probably. But consider the pattern of what we know and what we don't know. We know the comet carried organic chemistry. We know it erupted and vented material that hadn't been exposed to space for billions of years. We know JUICE collected 5-instrument science data that hasn't been fully published yet. We know Parkes observed on 3 occasions and hasn't released results. We know the comet is passing Jupiter in 10 days, and no official announcement has been made about whether Juno will observe it. And we know that the comet, after March 16th, is gone. Not gone in the sense of fading from view. Gone in the sense of beginning a journey that will not end for 8,000 years. There is no follow-up mission. There is no second chance. Scientists confirmed in 2025 that no spacecraft launched from Earth after July 1st, 2025 could intercept 3 I/Atlas. The delta V required is beyond any existing propulsion system. A mission from Mars could have done it in early October 2025 if we'd had one ready. We didn't. The best we had was a Jupiter-bound spacecraft that happened to be in the right place and a fleet of Earth telescopes that worked around the clock for 9 months. What those instruments found is still being assembled. What Parkes found has not been released. What JUICE's spectrometers found is coming at the end of March. And on March 16th, 2026, an object from another star system will pass Jupiter, the last planet it will ever pass, and pick up speed as Jupiter's gravity curves around it and head outward past the orbit of Saturn, past Uranus, past Neptune, into the Kuiper belt, into the scattered disk, into the inner Oort cloud where sunlight is too faint to see by, where the temperature is just a few degrees above absolute zero, where it will travel for 160 years before reaching the halfway point of its exit. From our neighborhood, the universe sensed something here. It crossed billions of years and billions of kilometers, and it arrived in exactly the right window for us to look at it with the most powerful instruments we have ever built. And now it's leaving. 10 days on the clock. If you're watching this and you want to be here when the JUICE full results drop at the end of March and when the Jupiter encounter data starts to come in, subscribe right now and turn on notifications. Not later, now, because when the data drops, it will move fast and the window to follow it in real time is short. This channel is going to go through the JUICE spectrometer results instrument by instrument, molecule by molecule, the day they're published. I'm going to be here if Parkes finally releases its data. I'm going to cover whatever Juno does or doesn't do at Jupiter on March 16th in detail. Like this video if you made it this far and you feel what I feel about this story, that we were handed something extraordinary and we're still not sure what it was. That means more than you think. It puts this in front of people who should be watching it. And leave a comment. What do you think the JUICE spectrometers found that hasn't been told yet? What's the detail you think nobody is prepared for? I read every single comment. I'll be in there. 10 days, then it's gone. I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.